have this green bar in the way here. Okay. So welcome to What's Up Over Edmonton for September 2023. My name's Jeff Robertson, and I'm a member of the Royal Astronomical Society of Canada Edmonton Centre. And this picture here is Venus at inferior conjunction, which happened last month. And it was, this is where inferior conjunction is where a planet inside Earth's orbit passes between Earth and the sun. So this is something that we would see in daylight. And one of our members, Murray Paulson, snapped this picture, and the details are in the picture itself, of a very, very thin crescent Venus as it passed below the sun. And Venus is now moving into the morning sky. And if you get up before dawn, you can see it popping up higher and higher each day. I call this What's Up Over Edmonton because the skies over Edmonton are fundamentally different than what is presented in most popular astronomy publications like Astronomy Magazine and Sky and Telescope. And the example that I've always used is this is the sky over Toronto on July the 5th at 11 o'clock. The southern constellation Scorpio, or Scorpius, right here, is fully above the horizon from its head to the tip of its tail and its stinger. While in Edmonton on that same day, all we ever see is the top of the constellation. We'll never see the tail, we'll never see the stinger. And it's not only what we can see in Edmonton that is different than further south, where most popular publications are aimed at, it's how we see them. And this is a picture I took of the moon, Jupiter, and Venus back in February, when they were all in a nice line. And you can see that they are on a bit of an angle, with the moon at the top left and Venus at the bottom right. On that same night, my wife's cousin happened to be in Buenos Aires, Mexico, which is 20 degrees north latitude, took a picture that same night of the same object, and you could see the moon at the top, Jupiter in the middle, Venus at the bottom, and they're all in a straight line going down to the horizons, because the angle of the ecliptic is just that much higher the further south you go. Most of the information I use comes out of the Observer's Handbook. I also use Astronomy Magazine. The Observer's Handbook is 352 pages of just about everything an observer could ever want to know. It is put out by the RASC every year. What do we have in the sky in September? We got falling leaves, but the weather is still good. So we've got Saturn. It's up all night. And Venus is shining brightly in the pre-dawn sky. The zodiacal light is visible in the pre-dawn sky from about the 14th to the 24th from a dark sky away from the city lights, and it will be, well, pre-dawn sky, it'll be in the east. We have the autumnal equinox on September the 23rd, the astronomical beginning of fall. And we may have a naked eye comet in September. This is something that was discovered fairly recent. It was discovered actually in August. So we'll see. Comets are notoriously unpredictable. Now, we'll go to the planetarium section, the sky in September. And as always, I have pre-recorded it. So let's have a look at what's in the sky over Edmonton in the month of September. And as always, we'll begin with sunrise and sunset times. So on September the 1st, the sun rises at 6:42 a.m. It sets at 8:23 p.m. for 13 hours and 40 minutes of daylight. Astronomical twilight ends, that is, night begins at 10:36 p.m. On the 30th, the sun rises at 7:33. It sets at 7:13. And as we've passed the equinox, we have 11 hours and 39 minutes of daylight. Night begins at 9:10. So let's talk about the planets in the evening sky. And for the last time this year, I'm going to talk about Mars. Mars reaches superior conjunction, that is, it swings behind the sun from our point of view in November. But in September and October, it is so low in the evening sky, you just can't see it. So on the first of the month, Mars sets 10 minutes after the sun. I doubt you'll be able to see it with the naked eye. You might be able to catch it with binoculars very low on the horizon just before it sets. By the end of the month, Mars is setting at 7:37. So let's switch to stuff we can see, and let's start with Saturn. Saturn reached opposition late in August, and in September it is up all night. It is a naked eye planet, but in a telescope you can see its beautiful ring system. And you can even see some of its moons circling the planet. In the August What's Up, someone asked me about Saturn's rings and whether they would disappear in the future. Saturn is tilted on its axis about 26 degrees, and as it circles the sun on its 29-year orbit, the angle of the rings, how open they are and how closed they are, changes from our point of view. And in the spring of 2025, the rings will be edge-on as seen from Earth, and they will disappear for a few months and reappearing as the tilt changes from our point of view. But right now the rings are a beautiful sight and can be seen even in a small 60 millimeter refractor. You can make out the rings of Saturn. So check it out. It's well placed in the sky in the fall, and the weather is still warm. At the beginning of the month, Saturn rises at 8:16. By the end of the month, it's rising at 6:19. Moving on the ecliptic to Neptune. The 8th planet in our solar system, Neptune, is visible in binoculars, and in a telescope it presents this pale blue disk. You may even be able to make out its giant moon Triton. Neptune rises at the beginning of the month at 8:50. It is at opposition, that is, it will rise as the sun sets on the 19th of September, and by the end of the month it's rising at 6:54. Let's move down the ecliptic to the king of the planets, Jupiter. So Jupiter is up for most of the night. It doesn't reach opposition until November, but at the beginning of September it's rising at 10:13, and by the end of the month it's rising at 8:17. And of course we can see not only the planet, but we can also see its 4 big Galilean moons. In this view we've got Io and Europa. Let's just zoom out a bit here. And Callisto and Ganymede. This view here is September 15th at 10:30. And as I've pointed out before, you can watch the moons change from night to night as they dance around Jupiter. And let's just move on to Uranus. Beginning of the month, Uranus rises at 10:22. By the end of the month, it's rising at 8:27. And through a telescope, Uranus is this very pale blue, almost an aquamarine disk. It can be seen in binoculars, and from a very, very dark sky, you can even make it out with the naked eye if you know exactly where to look. Switching to the morning sky, we have Venus well up at 6 o'clock in the morning on September the 1st. Venus will be dominating the morning sky for the next few months. And if we look at Venus through a telescope, it presents a very nice crescent phase. And through the month, as Venus gets higher and higher in the sky, more and more of the planet is illuminated, but it is getting smaller. It is actually moving away from us in its orbit. Now at 6 a.m. on the 15th, Mercury starts putting in a brief appearance in the morning. We'll just advance day by day. Doesn't stay too long before it falls back. And by the 29th, it's gone by 6 a.m. Let's look at the moon through the month. On the 3rd, it's approaching Jupiter. On the 4th, it is past Jupiter and is near Uranus. On the 5th, it is past the Pleiades. On the 11th, it is passing Venus at quite a distance away. On the 14th, the moon is new. On the 26th, it's a waxing gibbous moon passing Saturn. Following 2 nights, it's passing Neptune. And on the 30th, it is approaching Jupiter. On the 29th of September, the moon is full, and as it is the closest full moon to the autumnal equinox, it is called a harvest moon.
Oh, shine on, harvest moon, up in the sky. I ain't had no lovin' since April, January, June, or July.
It's called that because the bright moonlight would assist farmers as they were getting their crops off, providing an extra light to help them. The biggest effect of the harvest moon is that the moonrise times are not very far apart from day to day. And that's because the moon's orbit is tilted the smallest amount to the horizon at this time of year. And it appears more parallel with the horizon. The further north you go, the greater the effect of the moon rising only a few minutes after it did the previous day. In March, this effect is reversed. The moon rises well over an hour after it did the previous day. So here are the moonrise times for Edmonton. On the 28th, day before full moon, the moon rises at 7:20. On the 29th, the day of the full moon, it rises at 7:30. And on the 30th, the day after, it rises at 7:41. Now, normally, moon rises are average about 45 minutes to an hour after the previous day, but around harvest moon time, so you can see the difference is only 10 minutes. Now, as I said, the further north you go, the greater the effect. So let's go to Toronto, because I like to pick on Toronto. On the 28th, it rises at 6:35. On the 29th, 6:58. And on the 30th, 7:20. So, like a 20-minute gap, where here we have a 10-minute gap. Now, before we leave the moon, one last thing. On September 22nd, you can see the Lunar X. It's a transitory feature that appears for about 4 hours, and it's a result of light shining on the tops of craters around the crater Lunar. And here we see some pictures of the Lunar X that I've taken, and there's also the Lunar V, which is above it. So check it out, starting about 9:30, goes till just after midnight. You can see the Lunar X. You will need a telescope to see it. Now we have a comet to talk about. There is a new comet in the sky, and it is Comet C 2023P Nishimura, named after its discoverer. It may be a bright one. Comets are notoriously unpredictable. So far the signs are looking good, but of course it could all go wrong if the comet collapses as it nears the sun. So on September the 1st, and I've set the time here for 5:45 in the morning from Edmonton. So we've got Venus in the sky, and let's zoom in here. Nishimura is in the constellation of Cancer on the 1st. Zoom up a bit. And from day to day, it moves very quickly from Cancer into Leo. On the 9th, they're figuring it's going to get bright enough to be visible to the naked eye. Of course, it's getting lower and lower. And by the 11th, and this is where it's going to be at its closest point to the Earth. It's an early morning object. It's going to be fairly low to the horizon. As I say, this is 5:45 in the morning. Let's back up the time a little bit here. Yeah. At 5 o'clock, it's right on the horizon. At 6 o'clock, it's still high, but the sun is starting to come up. So give it a go. It might be exciting. Here's a finder chart of where to look, and a photograph or an animation of the comet, it could be a good one. If you're in a dark location for the middle of the month, from say September the 13th through 22nd, if you look east before dawn, like an hour or so or a couple hours before dawn, you may see the zodiacal light, which is sunlight shining on particles of dust along the plane of the solar system. And this picture shows it'll look like a pyramid coming off the horizon of this grayish light. It's sometimes called the false dawn because it would rise up before the sun. So look for that, but you have to be away from the city, well away from the city, in a truly dark sky, and it will be in the eastern sky. In the fall, it's in the eastern sky. In the spring, it's in the western sky. The autumnal equinox occurs at 12:50 in the morning of September 23rd. And this is where the sun crosses the equator on its way south. Equinox means equal night, so it means the hours where the sun is above the horizon and below the horizon are roughly equal, about 12 hours each. This is the beginning of astronomical fall, and of course the seasons occur because of the Earth's axial tilt of 23.5 degrees. Some of the deep sky objects we can look at, and I must say fall is the best time to get outside and look for deep sky objects because the weather is still nice and the sun is going down fairly early. So looking north, there's a few of my favorites, and I'll just turn on the labels here. First one is a couple galaxies in Ursa Major, M81 and M82, and they're fairly close together. M81, or Bode's galaxy, is a beautiful spiral. It's about 10 million light years from Earth. And above it is M82, also known as the Cigar Galaxy because of its shape. And it's about 11 million light years from Earth. They look great in a telescope. Last month we were looking toward Perseus because of the Perseid meteor shower. It's over now, but there are two open clusters in Perseus known as the double cluster because there are two open clusters that are fairly close together. NGC 869 and NGC 884. You can see these in binoculars. They'll look like faint smudges, and in a telescope you can resolve the stars within these two clusters. Above the double cluster is the owl cluster, which I've talked about before. It's one of my favorite objects to show people because it actually looks like an owl. In this case, an upside-down owl with its two eyes and its wings spread out on either side of it. And while we're in that area of the sky, can't forget the great galaxy in the constellation Andromeda, M31, the closest spiral galaxy to our own Milky Way. There it is there. It's quite a large object. It's about 2.5 moon diameters across, so it's a pretty big object. If you have a narrow field telescope, you're not going to get the whole thing in there. And I find the best way to find Andromeda is to find these two stars in the middle of the hind legs of Pegasus and just draw a line straight up, and you'll bump right into it. You can also go from the tip of the bottom of this part of the W from Cassiopeia and draw an angled line to it. You can see it in binoculars. Even in the city I can see it in binoculars, but it's just more of a smudge. You really have to get out of the city, away from the lights, to fully appreciate Andromeda. And just shifting over to a different part of the sky, we have Brocchi's cluster, or the coat hanger, and it actually does look like a coat hanger. And I've talked about this sky in previous issues of What's Up. It's a wide object. Again, a narrow field telescope, you aren't going to get the whole thing. In my own 8-inch Schmidt-Cassegrain, I cannot see the whole coat hanger in my telescope, but in my finder I can see the whole thing. And while you're in the vicinity of the coat hanger, check out the Dumbbell Nebula. It falls within the Summer Triangle, and it is a planetary nebula, and it makes a beautiful sight in a telescope. And if you look to the southern sky, there are lots and lots of objects to look at. Nebulas, open clusters, planetary nebulas, all sorts of stuff. I'm going to mention a couple things going on in September. The first one is on September the 3rd, and this is at the Astotan Lake Day Use area inside Elk Island National Park. We are having Milky Way Day. Now, this was an annual event up until 2020 when the pandemic put a hold on things. We last had it in 2019. So, for 2023, we're kicking it off again. We'll have solar viewing from 2 till 5 in the afternoon. We'll have a guest speaker, well, actually speakers from the U of A talking about the AlbertaSat 2 program. And then from 9 until the people leave, we'll have nighttime viewing to see some of the objects that I just talked about. Later on in the month, RASC Edmonton presents the Northern Prairie Star Party, and that is out at Black Nugget Lake. It runs from the 12th to the 17th. The big day is on Saturday the 16th. They will have special guest speakers and a barbecue afterward, and then followed by observing. You can come out for the whole time and camp. It's at the Black Nugget Lake campsite. There are costs involved, or you can just come out for the day, pay your registration fee. Details for both events are on our website, edmontonrasc.com. And with that, I'll close this section. Okay, are there any questions before I continue on? Okay, go on to the moon.
What do you see when you look at the moon? When it's full and round, do you see a balloon? Does it look like a cookie with the bite taken out? What do you see when you look at the moon? It follows a path every month of the year.
Okay, third quarter is on September the 6th. The moon is new on the 14th. First quarter is on September the 22nd. And the moon is full on September the 29th. As I mentioned before, it's known as the harvest moon, being the closest full moon to the equinox. It's also known as the moose calling moon, the corn moon, the song moon, don't know why, or the barley moon. And for the lunar features, I take them out of either the Explore the Moon program for binoculars or telescopes that's put out by the RASC. And today I'll pick one from the telescope or from the binocular program. And it is triple craters or centerline craters. There they are there. They're best seen around the first quarter, which in September is the 21st and 22nd. And it is three large craters. You can see them there all in a line. The first one is Ptolemus. There it is there. It's a 153 kilometer wide crater. It's 2.9 kilometers deep. It's quite old. It's about 3.9 billion years old, occurred during the heavy bombardment era, and it's got a lava-covered floor. It's named after Ptolemy, who was a 2nd century Greek astronomer who gave us the geocentric solar system that was used up until the time of Copernicus. The next one is Alphonsus, and it's a 119 kilometer wide crater. It's 2.7 kilometers deep. It has a 1.5 kilometer high central peak. Interesting note, it was the impact site of Ranger 9, which was the last of the Ranger probes to take close-up pictures of the moon back in the mid-60s, and it is named after a 13th century astronomer, and there it is there. It's also about the same age as Ptolemus. And the last one is RASC, which is the smallest of the three. It's 97 kilometers wide, 3.6 kilometers deep. It's the youngest of the three. It's about 3.5 billion years old. It does have a large central peak that's 1.5 kilometers high. And it was named after an 11th century astronomer. These three craters can be seen in binoculars, and of course, they can also be seen in a telescope. Now, in the last couple months, I picked the constellation Aquila and Lyra, as these constellations contain the brightest stars that form two of the three corners of the summer triangle. So continuing on this path, we're going to look at Cygnus, which contains the third star from the triangle. So this is the star field where Cygnus resides. Cygnus is a swan, and there is the astronomical drawing of the constellation. Cygnus is informally known as the Northern Cross, and you can see why. And here is what the ancients saw when they gazed up into the sky. And there are several stories in Greek mythology pertaining to Cygnus. In one, the Spartan queen Leda is seduced by the god Zeus, who had transformed himself into a swan. Now, how that seduction worked, I have no idea, and I'm not even going to think about that. In Wilfred Buck's book, Night Sky Stories, he wrote the Cree people called this constellation Niska the Goose. And the story goes that hunters returning at night from the day's hunts would hear the whistle of geese wings, and looking up would see the silhouettes of geese moving across the backdrop of the Milky Way. And the elders would say the Milky Way is the path the geese follow to travel north in the spring and south in the fall. And this is a photo I took of the area of sky where Cygnus resides. It's only a 15-second exposure, but Cygnus does lie right along the Milky Way. And I hope it shows up in this picture over the internet. And I've drawn in the constellation lines in that photo. Cygnus is awash in objects for the observer. In the September 2023 issue of Astronomy magazine, Phil Harrington writes a column about some of the sites viewed in binoculars, and he says there's almost 100 of them. And by coincidence, about an hour and 15 minutes ago, Luca Vanzella, who's one of our members, posted a message on our Astro list entitled Winging It with Cygnus, where he listed 9 objects he observed in an observing session. Well, actually 10, but one of them is one of the ones I'm going to talk about. Cygnus is home to the first black hole discovered, which is known as Cygnus X1, which is also the name of a 10-minute long song by Rush. And there is Cygnus. That's the location of Cygnus X1, but of course it's a black hole, so you can't see it, so that's all I'm going to say about it. Deneb, which forms the tail end of the swan or the goose, is the brightest star in the constellation, and it shines at a magnitude plus 1.25. While the other 2 stars of the triangle are astronomically quite close to us at 17 and 25 light years, Deneb is between 1600 and 2600 light years away, depending on who you ask. Deneb is a blue-white supergiant star with a solar radius 203 times that of our sun, with a surface temperature of over 8,500 degrees Celsius. And with about 20 times the sun's mass, it will one day collapse and form a supernova. So that would be something to see. Albireo, circled here, is the second brightest star in Cygnus, and it is at the head of the swan or goose, and to the naked eye it appears as a single star. But in a telescope, it resolves into a double star, which is quite striking. It's one of the stars is an orangey gold color, and the other is a dimmer blue one. From our perspective, the two stars appear close in the sky, but astronomers don't believe they're gravitationally bound to one another. However, the contrast between the two is so striking that Albireo is considered one of the most beautiful double stars, and it is a favorite target at the RASC observatory in Coronation Park during the fall. In fact, last Saturday we were looking at it before Saturn came above the trees. The brighter of the two stars is about 430 light years away, and the dimmer blue star is around 400 light years away. Last object I'm going to talk about is a target for telescopes, and it is the Veil Nebula, and it's a cloud of ionized gas and dust. And this program actually presents it pretty accurately as how it looks to the naked eye. It's most pictures I see are it's nice and colorful, but of course our eyes can't see those colors. It's the remains of a star 20 times more massive than the sun that ended its life exploding as a supernova between 10 and 20,000 years ago. The remnants of the explosion have expanded to cover an area of sky roughly 3 degrees in diameter, or about 6 times the diameter of a full moon. And it's estimated that the nebula is about 100 light years across. The veil has 2 distinct parts known as the Eastern Veil, and it has a designation of NGC 6992, and that's the one on the left, and the Western Veil designated as NGC 6960. And recent measurements place the nebula at approximately 2,400 light years from Earth. So we'll go to space history now. And this is where we look at a past event that not only occurred in this month, but whose anniversary year is divisible by 5. So in 2023, it's years ending in a 3 or an 8. As this segment is about endings, let's start with a classic movie ending.
It might be a good idea for you to disappear from Casablanca for a while. There's a Free French garrison over at Brazzaville. I could be induced to arrange a passage.
My letter of transit? I could use a trip. But it doesn't make any difference about our bet. You still owe me 10,000 francs.
And that 10,000 francs should pay our expenses.
Our expenses?
Mm-hmm.
Louis, I think this is the beginning of a beautiful friendship.
So you may be wondering what the final scene from one of my favorite movies has to do with space history. Well, let me explain. It's about the end of the Galileo mission to Jupiter. Galileo's mission lasted from 1989 to 2003. Galileo had orbited Jupiter in a long elliptical path 35 times in almost 8 years. Each orbit lasted about 2 months, and it made close passes to all 4 of Jupiter's big moons. Its instruments allowed scientists to determine, among other things, that Jupiter's icy moon Europa probably had a subsurface ocean with more water than the total amount found on the Earth. That the moons Callisto and Ganymede also likely have liquid salt water beneath their surface. Additionally, they found that Ganymede possessed its own magnetic field, the first planetary moon to possess a magnetic field. And that Io's extensive volcanic activity may be 100 times greater than found on Earth. And those volcanoes repeatedly and rapidly resurface the planet. Galileo also carried a small probe designed to enter Jupiter's atmosphere, and to this date it is the only probe to sample the atmosphere of a gas giant planet. It was deployed December 7th as Galileo arrived at Jupiter and sent deep into the atmosphere, taking readings for about an hour before the probe went silent. The probe's 7 scientific instruments detected less lightning, less water, but more winds than expected. Winds of up to 550 kilometers per hour were found. It was known the atmosphere of Jupiter was mainly composed of hydrogen, but it also detected nitrogen, carbon, and sulfur. Clouds of ammonia and ammonia sulfate were much thinner than expected, and the clouds of water vapor were not detected at all, even though they expected to find some. Galileo's mission to Jupiter, and Jupiter had previously been visited by Pioneers 10 and 11 and Voyagers 1 and 2. These were flyby missions. Galileo would orbit the planet, studying it and its moons. Like the Pioneers and the Voyagers, it was powered by radioisotope thermoelectric generators, which use the heat of decaying plutonium to produce electricity. And as you can see in this picture of Galileo in its white room, it was quite a large probe. It stood 5.3 meters tall and weighed 2,223 kilograms. In flight, go to the next drawing here. In flight, part of the spacecraft would spin for stability, while the other part was despun to allow instruments, including the scan platform, and that's sitting on the back part of the spacecraft, to maintain the scan platform, which had the imagers to maintain a lock on their targets to study. The spacecraft carried a number of instruments, among them a solid-state imaging camera, near-infrared mapping spectrometer, ultraviolet spectrometer, photopolarimeter, plasma investigation device, plasma wave subsystem measurer, dust detector, heavy ion counter, and a large magnetometer, which is that big boom that sticks out to the side on the right-hand side of this picture. And as mentioned before, it also carried a probe that would drop into Jupiter's atmosphere. Galileo was originally going to be launched from the space shuttle using a Centaur upper stage, which is a stage still used today. It's a cryogenic stage. It uses liquid hydrogen and liquid oxygen for fuel. It's an extremely powerful rocket, extremely reliable rocket. That was the original plan. And with the Centaur upper stage, Galileo would fly directly to Jupiter in less than 2 years. After the Challenger disaster, NASA forbid carrying a liquid-fueled rocket aboard the shuttle. And Galileo was designed from the beginning to be launched from the shuttle, and retrofitting it to ride on a rocket like the Titan IV just was not possible. So a new plan was needed using the less powerful inertial upper stage, which was a solid-fueled rocket, to launch Galileo from the space shuttle. A new flight plan was devised using gravity assist of planetary flybys to give Galileo the speed to reach Jupiter. But instead of less than a 2-year voyage, it would now take over 6 years. Galileo was launched from the space shuttle Atlantis on October 18th, 1989.
Ground telemetry is confirming Shannon Lucid's report of tilt table motion. The tilt table was at 29 degrees. It's now moving up to an elevation of 58 degrees. That's the deploy attitude. And the Sunnyvale flight director has just confirmed the successful deploy of the inertial upper stage and Galileo. Galileo reports positive telemetry of deploy. Also, we see the orbiter performing a minus X translation maneuver to move away from the IUS Galileo stack.
Time, Houston. The spacecraft is stable. Galileo is on its way to another world. It's in the hands of the best flight controllers in this world. Fly safe.
So because of Galileo's use of planetary flybys for gravity assist, it didn't head to the outer solar system at first, but flew inward, getting a gravity assist from Venus on February 10th, 1990. It then got 2 more boosts from Earth, first on December the 8th, 1990, where it was flung past Mars into the asteroid belt, and there it made the encounter with Gaspra, an 18 by 12 kilometer long asteroid. And it was the first close-up pictures of an asteroid that were beamed back to Earth. It returned to Earth on December 8th, 1992, and Galileo received its third and final gravitational boost to send it to Jupiter. And this is a series of pictures Galileo took as it flew past Earth and flew away. You can see it getting smaller. On the 21st of August, 1993, Galileo encountered its second asteroid, Ida, which was 60 by 25 kilometers. And it surprised scientists by having a small moon less than 2 kilometers across orbiting it. And you can see it sitting there on the right-hand side of the picture next to the larger Ida. Now, in March of 1993, a comet was discovered orbiting Jupiter named Shoemaker-Levy 9 after its discoverer, Eugene and Carolyn Shoemaker and David Levy. It had an unusual appearance, described as a squashed comet by one of its discoverers, and it was quickly determined that the comet had actually been torn apart by Jupiter's gravity into 21 pieces, and it would impact Jupiter in July of 1994. The impact would happen on the side not facing Earth, but it would be seen by Galileo. So starting on July the 22nd, 1994, pieces of the comet impacted Jupiter's atmosphere, each releasing more energy than our largest hydrogen bombs. The impacts were captured by Galileo's cameras, and you can see the brightening of the flash as the comets entered Jupiter's atmosphere. Now, from Earth, as the impact sites rotated into view, scientists were astounded that there were black scars in the atmosphere of Jupiter, and even amateur telescopes could see these black scars on the surface of Jupiter. On December the 7th, 1995, Galileo arrived at Jupiter, fired its braking rocket, and entered orbit. And it was the first spacecraft to orbit a planet in the outer solar system. Now, these last 2 slides are named the Rocky Road to Jupiter, not just for the extended time it took to get there, but due to the problem that could have scuppered the whole mission. When Galileo arrived at Jupiter, it was supposed to look like this. Instead, it looked like this. The high-gain antenna, which was needed to communicate with Earth, did not unfurl properly. In the original flight plan, this 4.8 meter wide wire mesh antenna, which folds up like an umbrella, would open immediately after launch. It was held closed by 18 motor-driven latches that had a dry lubricant on them. Because of the change in the flight plan to fly inward past Venus, and that the mesh could be damaged by heat, it was decided that the antenna should remain closed until after it flew past Earth for the first time. And additionally, a sunshade was added to the spacecraft. You could see that disc right below where the antenna is. The spacecraft was transported by truck to California, where it was built, and then back to Florida, where it was put in storage in the time where it was supposed to launch in 1986 to the time it actually launched in 1989. And it's believed that vibration of the 2 cross-country road trips removed the lubricant from some of the latches. And it should be noted that the latches which did not release were on the underside of the spacecraft when it was trucked, and it was trucked laying on its side. Controllers tried cycling the latches, turning the craft toward then away from the sun to heat and cool the latches. They even used its thrusters to shake the craft, trying to open the antenna, but to no avail. So instead of using the high-gain antenna, which transmitted at a rate of 134,400 bits per second, they would have to use the low gain antenna, which transmitted at 160 bits per second. Galileo had an onboard tape recorder, so data could be recorded on magnetic tape and transmitted to Earth via the low gain antenna. And there was problems with the tape recorder too, but I'm not going to go into that. Improvements were made to the deep sky network, the 3 dishes on Earth that talk to probes in the outer solar system. And new software was uploaded to the spacecraft to compress the data, and they managed to get a bit rate up to 1,000 bits per second. But there wouldn't be any live images coming back like there were during Voyager. Those of us old enough to remember might have watched coverage on PBS of the Voyager encounters, and these live pictures would come back from Jupiter and Saturn. There wouldn't be any of that with Galileo. It would take hours or even days to download a single picture. In the end, Galileo completed its primary investigations. A mission extension gathered data that would be studied for years. Its fuel almost gone, its electronics damaged by Jupiter's intense radiation, and in order to prevent contamination, should the craft impact Europa, a place where life may exist under its giant ocean, controllers directed the craft into Jupiter's atmosphere on September 21st, 2003, so 20 years ago this month, where it was completely destroyed.
And though you leave behind a silver lining, it's you must go and I must find.
Heavens Above is a great source for all things astronomical. Finder charts for this new comet are on there right now. You can put in your location, your time, your day, and it will print you a custom finder chart for the comet or anything else. It also has satellite times, rise and set times of the planets, the moon, the sun, etc. Next session is what's up for October is going to be Wednesday, October the 4th at 7:30 p.m. Now, I'm going on a trip at the end of September, and I'm getting back the day before. I'm getting back on October the 3rd. So what's up for October is going to be in the can before I leave. So it'll be done by about the 15th of September. So if there's anything that comes up after that, I won't be able to talk about it because it'll be done, just so you know. Next RASC regular meeting is on Monday, September the 11th at 7:30 in the Ziedler Sky, in the Ziedler Dome inside the TELUS World of Science, or it will be on Zoom. And there's links on our website, edmontonrasc.com. And with that, I'll say thank you. And if there are any questions, I see something in the chat here. Thanks, must run. Okay. Thanks, Alistair. That's it. So is there any questions, comments, rotten eggs, tomatoes, anything?
Nice job again.
Whoa.
Go ahead. Go ahead, Jay.
Oh, I was just saying, nice job, Jeff.
Oh, thank you.
It's always very informative.
I heard a statement the other day that we can only see 1,000 light years, stars that are less than 1,000 light years away. And yet you say Deneb was, I think, 2,500 light years away.
Yeah.
Am I missing something?
Yeah, it's not true. I mean, you from a dark site, you can see the Milky Way, or pardon me, you can see Andromeda, and it's 2.5 million light years from here.
Yeah,
and the globular clusters, like you can see M13 as a fuzzy patch with the naked eye, and it resolves in binoculars, and it's like 25,000 light years away. So whoever said that is wrong.
Okay, just leave it at that.
Yeah.
Okay. Thank you.
Yeah, you're welcome.
Jeff, what did Casablanca have to do with that space mission?
Oh, because it was the end of Casablanca. and it was the end of Galileo. So I was kind of debating Casablanca or Planet of the Apes. So I went with Casablanca.
You still lost me. I don't.
Oh well, it was the end of the movie, and it was about the end of the Galileo mission. So that's all. That's all. It was just about being the end, right?
The end of. Okay.
Yeah, the end. The end of the mission, the end of the movie, and I happen to like Casablanca. It's one of my favorites, and it's got so many iconic lines in it that we still use today.
Yep.
Including one that actually wasn't in the movie. No one ever said "play it again, Sam" in the movie. Certainly not Bogey. Ingrid Bergman said, "Play it, Sam. Play time as time goes by." He said, "I don't know. Mr. Rick don't like that song."
Yeah, it was a great movie. I think I've seen it about 40 times.
Yeah, I've probably seen it that many times too. So, yeah.
Did you get enough volunteers for this weekend?
I believe we're good for volunteers.
Good.
And hopefully, the weather forecast was not looking good yesterday, but it's looking better now. So I am hoping that we have good weather. We'll be there anyway because we have our speaker to attend to from the U of A, and hopefully we'll have our solar observing and hopefully we'll have nighttime observing, because the last couple of years in 2018, 2019, we got clouded out and rained on. I think 2018 we got rained on. 2019 we just got clouded out. So I'm hoping for good weather. Okay. Well, if there's nothing else, I will say thank you very much for taking time out and watching this presentation, and hopefully we'll see you again next month on October the 4th. So I'll say good night.
Thanks, Jeff.
Yep.
Thanks, Jeff.
Thank you.